Newton's first law.
Newton's second law.
Newton's third law.
The ball wants to keep going up, but it can't because gravity weighs it back down. This ball is going to stay here forever unless it's acted upon by any outside force.
Hi guys! Today we're going to be talking about Newton's first law of motion. Does anyone know what that is?
Is that the one about inertia?
Yeah! Newton's first law states that objects will remain at rest or in a uniform motion in a straight line unless acted upon by an external force. This essentially means that everything wants to keep doing what it's already doing.
Sounds pretty lazy to me.
You could think of it that way. As an example, if I throw a ball, the ball technically wants to keep moving forever and ever, but it doesn't. Does anyone know why?
Gravity?
Yeah! Gravity weighs the ball down and it falls to the ground. In other cases, it would hit something like a tree or a wall. All those are examples of outside forces.
Does that mean that if you throw a ball in space, it'll keep going forever because there's no gravity in space?
Yeah, it will keep going forever unless it hits something. I can show you guys an example. These rocks in space are going to keep moving forever unless they run into something. Also, in space, if you pick or throw something, you will start moving too, but that's something you'll learn about later when we talk about Newton's third law. The first law of motion is found everywhere, and there are so many examples. For homework today, you guys are going to find 3 of your own examples and share them in class next week. See you guys later.
Bye.
Bye.
Force equals mass times acceleration.
Force is any push or pull. Mass is the amount of matter in an object. Acceleration is the rate at which velocity changes. With the bicycle example, the second law is demonstrated as you put force on the pedals. You and the bike make up the mass, and the acceleration is demonstrated by how fast the bike is moving. The more force I put on the pedals, the higher the acceleration. Therefore, the faster I go. Let's say I wear a backpack as I'm biking. The mass increased, so I will have to use more force.
Force is used everywhere, even opening doors. The mass of the door determines how much force you use, and the more force, the faster the door will open. If I open a door at 1 meter per second, and the mass of the door is 3 kilograms, what force am I putting on the door to open it?
Is it 3?
Yes, and because we are multiplying kilograms by meters a second, we use a measure called newtons.
Named after Isaac Newton?
Yes, you got it. Swings are another great example of Newton's second law. When someone pushes you on a swing, they use force to move your mass, making you move. If I go 2 meters a second and someone pushes me with 8 newtons, what is my mass?
3 kilograms?
Actually, when you divide 8 by 2, you get 4.
Yes, Olivia, great job. And that's a wrap on Newton's second law.
Hello everyone, please turn your cameras on so we can start class. Okay, thank you. Today we are learning about Newton's third law of motion. This law states that if one object exerts a force on another object, then the second object exerts a force of equal strength in the opposite direction on the first.
Is that why when we touch an object, our hand doesn't go through it?
Exactly, that's why we can't go through windows or walls, because both walls and windows push back at us. You can also think of it as every action has its equal opposite reaction.
Is this the law of conservation of momentum?
Yes, another good example is when you play pool.
Oh, like how you hit the white ball with the cue and it hits one and they all hit each other, causing a chain reaction?
Yeah, and also when you break, all the balls scatter. Can anyone think of another example?
Maybe bowling? Because when the ball hits the pins, they fall over and it doesn't go through them?
Perfect. Does anyone have any questions?
Well, what happens with water in a glass?
When the water goes into the glass, the water doesn't go through the glass because the glass pushes back at the water.
Does that mean that ghosts don't follow the third law of motion?
Yeah, because they can go through walls, right? That's all the time we have today. Homework is on Blackboard. Have a great rest of your day.
Thanks, bye.
Bye.